Hello friends, good afternoon. This is Abhishek Kumar and we are discussing moment distribution method. Dear friends, however, the basic concepts of moment distribution method and general question on moment distribution method has been completed. But now we will deal with some good quality questions which are generally asked in competitive exams, or they have some different type of concept. Let us see those type of questions. Okay friends, we were discussing sway analysis. Dear friends, in the last topic, if I told you, if loading is only on the joints, if loading is only on the joints, for example, this is loading, this is 100 kilonewton. Now when you will do non-sway analysis, means you will apply a support here and calculate reaction. By the observation, you can say that the entire 100 kilonewton load will be transferred to R. Means these reactions HA and HD will be 0. Means the total 100 kilonewton will be transferred in this leg. There will no bending of this member and of this member because there is no load in this member. So we can say that R equal to 100 kilonewton directly. So sway force will be 100 kilonewton, right? Or we can observe that if we take the equilibrium, since if we want to take the equilibrium, this vertical leg, we will cut it here. We will not include this 100 kilonewton here in this because 100 kilonewton is in this leg only, right? So we will cut here. This will be HA, for example, this is HA, and it may be some moment which is 0, which we have already calculated because there is no bending of this member, and there may be some shear force here, some vertical force, and member moment is 0. Now taking the moment about B, you can say that MB, summation of MB equal to 0, this is point B, so you can say that 4 into HA equal to 0, means HA equal to 0. So you will remember now onwards that if loading is only on the joints, so the sway force will be equal to the force. But had the question been like this, this would be the question. Now what would you do? Now you would calculate the fixed end moment, thereafter distribute them, so you get some moments, the end moment, using them and those end moments, and this was the R. Now you can say that this 100 will use to bend this member, and then some portion of this 100 will be this R. So this R will not be equal to 100. So you can say that due to bending, here reaction will generate HA, here maybe reaction generate HD. So now the equilibrium will be HA plus HD plus R equal to 100. In the earlier case R was 100, but here R equal to 100 minus HA plus HD, and HAHD can be calculated using you will cut here, and since you have already done the non-sway analysis, so you have the end moments, non-sway end moments. So using those non-sway end moments, for example, this is MAB, this is MBA, you are known these values. Now you will say that this is shear force, this is vertical, this is, let us suppose, HA, this is vertical force, so this is B. Summation of MB equal to 0 about this point, and this is 100. We are looking the equilibrium of this leg. Now we can calculate HA, right? So in this manner we will do the moment distribution analysis. Let us see some good type of question. Dear friends, sometime in the question 3 legs are there. What the meaning of 3 legs? For example, this is the question. This is the question. Here is loading, here is also loading. Now if you will see that there are 2 intermediate joint A, B, C, D, E. One is joint B and other is joint C. We will calculate fixed end moment, assuming it has fixed. These will be 0, these two 0, 0, 0. we can calculate these, right? They will be, these two will be 0, and we can calculate like this, right? Now we can calculate the distribution factor at joint B and joint C. For example, at joint C distribution factor is some, and at joint B distribution factor has some value. So at joint C, let us suppose distribution factor is 0.5, and at joint C, let us suppose, since there are three members BC, BA and BE, so let us suppose distribution factor is 0.2, 0.4 and 0.4 plus 2, 6 plus 4 point, this will, summation should be 1. This is the distribution factor. Now you will distribute the moment, so you will make like this. This is D, right? This is joint C. This is joint C, and from C two members CD and CB. There are two members, and this is A, right? This is A, this is B, this is C, this is CD, this is CB, BC, BA. But how will I see this member BE? How can I see this member BE? So there is problem, because in 2D we can show only 2. So third will be like this, in like this. How can I? So for example, these distribution factor are 0.5, 0.5, and they are from C to B. This is this is B. So this is from B to C, this is B to A, and this is B to E. So B to C is 0.2 and B to A is 0.4. We are not showing B. Dear friends, remember one thing. At this joint, net moment should be 0, means BC plus BA plus BE should be 0. So we will leave this lag, and calculate only basis of this. So you can calculate. Let us suppose the values are this is let us suppose 0. This is 0. This is for example -5, and this is +5, and this value is -8. This is +8. For example, on the basis of this, now you will distribute. You will say that the total unbalanced moment, and also from B to E. B to E is 0. From B to E 0. So net moment is +5 into -8, that is -3. Distribute this -3 into 0.2, -0.6, and -3 into 0.4, -3 into 0.4, -1.2, and one portion will be -3 into 0.4 for this. Leave that, and remember this thing only. Now similarly you will like this +5, so it will be 2.5, it will be 2.5. You will distribute like this and analyze the frame, and finally you will get the answer. Let us suppose the answer is, this is -5, this is +2, this is -2, and here will be let us suppose this is -7, and this is +5, and this is +9. Now this is balanced, but this is not balanced. Reason behind is that summation of MB plus MBC plus MBA plus MBE, BC plus BA plus BC is 0, means MBC plus MBA plus MBE equal to 0, right? So MBC you know -7, and MBA +5 plus MBE equal to 0. So you can say MBE will be 2, right? MBE is +2. So you have all the three values. Now you will see that you have MBE, but what is the value of MEB? Since the joint is not going neither leftward nor rightward, only it is rotating, so joint B can be treated as hinge. This can be treated as hinge with applied moment. How much? MB equal to +2. So you can say that if you apply 2 kilonewton meter, half will be transferred here, 1. So you are in position to calculate all the movement. By this procedure we can calculate all the values. By this procedure we can calculate even in 3 lakh question. But if loading is also there in this lag, if in this lag also loading is there, so first of all we will search for that lag in which there is no loading. Here is loading, here is loading, here is loading. Now how will we calculate? So we will leave this lag. So look how we will calculate. For example, loading is also present in this lag also. Now you will calculate, this is A, B, C, D and E. Now you will calculate distribution factors, right? And you will calculate, for example, this is also. So in this case you will say that this is A, this is B, this is C and this is D, right? For example, A to B, let us suppose this is -5 plus 5. B to C, this is -7 plus 7. E to this is C to D, -6 and this is +6. And E to C, this is 3 and 3, for example, right? Now you will see, you will calculate the distribution factors. You will, for example, this is 0.5, 0.5 and this will be 0.3, 0.2 and 0.5, because net summation at C, CB, CD, CE will be 1. So 0.3, 0.2 and that is 0.5. Now you will see that now you will distribute the moment. You are leaving this lag, EC. You will say that M bar EC, M bar EC, M bar E to C is +3 and M bar C to E is -3, right? So you will say that at joint C, what is the scenario? At joint C, this is +7, -6 and C to E, this is C to E, -3. So net summation of +7 -6 -3 will be equal to -4. You will apply +4 moment, and on +4 you will distribute +4 into 3 means +1.2, +4 into 2 +0.8 and +4 into this. Its distribution factor will be 0.5 +4 into 0.5, that is 2, right? So we need not to take this, we will analyze using this. Now we will distribute this and this. From here unbalanced moment will come and it will again be distributed, and finally you will calculate the value. For example, this is -6, this is -4, this is +4, this is -4, here is +10, here is -7 and here is +12. These are the values. So you will see that at joint C, MCB plus MCD plus MCE will be equal to 0. So +10 -7 plus MCE equal to 0. Hence MCE will be 10 minus 7 plus 3, it will be -3. So this you are known, MCE equal to -3. Now how to calculate this MEC? If there was no loading in this lag, it will be half of this, but if there is loading, so you will calculate MEC equal to M bar EC, this M bar EC plus MCE minus M bar CE divided by 2. This will be the answer. Means MEC here will be MEC MEC equal to M bar EC. M bar EC means this is E and this is C. M bar EC is this clock plus 3, right, and plus MCE, this is MCE final, it is minus 4, so it is minus 4 minus M bar CE is anti-clock minus 3 and minus minus plus and divide by 2, so the value will be plus 3 and minus half and it will be 2.5. So in this manner we can solve the 3 lakh question using moment distribution method, right? Okay, now next now we will solve some good quality questions. For example, look, this is the most simple question. This is the frame. Analyze this frame using moment distribution method. So this is non-sway case, it will not sway, so because it is hinge here, so we will say that this is fixed, this is fixed, here 0, this is fixed, this is fixed, here 9, so it is hinge, so you will correct the moment and final answer will be 0 minus 13.50. You will calculate distribution factor 3EI by L and 4EI by L and 3EI by L. You will distribute and finally you will get the answer and draw BMD. Now next question is this. One thing is how to draw the deflected shape. Yes, deflected shape is the important thing, how to draw the deflected shape. Look, while drawing deflected shape, some things should be remembered. Listen, what are those things? First is, if this is fixed end, so frame can go or beam can go like this or like this, right? It cannot go like this because it is fixed, so either it can go like this or like this. Number one. Number two, if at rigid joint angle will remain same as it was earlier. For example, this is the beam, this is the beam, this is the beam. Either it will be like this, means it was earlier horizontal, now will also remain horizontal, right? Third, if it is 90-degree angle, it will remain 90-degree even after deformation. For example, if you will see this, so now 90 means, look, this one possibility is this, one member goes like this and other member goes like this, right? This is one possibility, right? Second possibility may be like this, one member goes like this and other member goes like this even after angle is 90. Third possibility may be this member like this and this member like this, right? These are the three possibilities at a joint. Look here, this is compression and this is also compression, so it is correct, because at a joint, if either it is sagging bending moment or hogging, sagging means either plus this side means this side compression, this side, or either both side tension. It is not possible like this. Here if you see this member, here is tension but here is compression, it is not possible, right? But it is possible, here is tension, here is also tension, it is possible. So these type of some things are possible like this. So using these we can draw deflected shape using BMD. For example, in this case, look, this is plus means compression means like this, because fixed beam, fixed joint either can like this or go like this. After that this is minus and this joint will not move, so it will remain here. So minus means this tension on top face, right? After that it is again tension, right? So structure will be like this, means this one, right? so like this. Now thereafter it is positive, so it will like this, and it is hinge, so it will like this. This is the deflected shape. Next question. This is the question. Look, this question. This is the guided roller. Means due to loading it will move in this direction, but there bending moment will present, right? It will not, here bending moment is not 0, means it is a fixed beam, so it is a movable fixed support. So guided roller can be idealized as movable fixed support, right? So if when we will calculate the far end, so we will take far end is fixed, because there is no here slope is 0, right? Here slope is 0, so far end will be treated as fixed, and this is far end is fixed, right? So when we will calculate stiffness, we will calculate BC and BA 4EI by L, 4EI by L. First of all, we will do non-sway analysis, means we will restrain it from this side, right, and calculate how much restraint force you have to apply. That will be equal to the sway force due to this loading, right? So in this analysis we do non-sway analysis. In non-sway analysis you will see that first of all you will calculate fixed end moment. This is 8, so it is 4, it is 4. It will be fixed, it is 16, it is 16. This will be fixed, and now you have restrained it, now it is completely fixed support, right? So now you can calculate distribution factor is half each, so we will distribute A, B, C. This is anti-clock means -4, clock means 4, minus and plus. Undistributed is plus, it is -12, right? So its opposite +12, so it's half, +6, it's half here, because this is fixed support now. So these are called as non-sway moment. Using these non-sway moments we can calculate the sway force using the equilibrium equation. For example, we will draw a structure like this and like this. We have restraint from this side, so this is R, this is 8, and for example let us suppose this is HA. So we will write R8 equal to HA plus R, and we can calculate R. First of all we need to calculate HA. We will see the equilibrium of this lag. So look how we will see equilibrium. This lag, this is B and this is A. At joint 3 forces will present: axial, shear and bending moment. So here bending moment A to B is -1. -1 means anti-clock, so it will MAB is anti-clock, -1, right? And B to A is +10. So it will be plus means clock, right? And one shear force, one axial force. Now this we will write summation MB equal to 0. We will write summation MB means net rotating force in this direction equal to net rotating in this. So in this direction will be 1 plus 8 into 2 and equal to 10 and into HA into 4. So HA will be 1.75, means direction is correct. Now we will calculate 8 equal to this, means R equal to this. So sway force will be 6.25, equal and opposite. So this is the actual sway force. Using this we will calculate the correction factor, right? Now we will do the sway analysis. Actually if I push the frame it will go like this and this and this, but during sway analysis we assume all the member as fixed. So this is fixed, this is fixed, this is fixed, this is fixed. Only we are applying this transverse delta, this, right? This is the horizontal delta. So it will be like this, but this beam it will move from here to here. So no fixed end moment due to sway. right? It will 0, it will 0, and it will be like 6 delta divided by L square 6. So ratio will be this 0 0, minus 1 0. So we can take minus 10 0 0, or you can take 100 minus 100, you can take any value, right? Now again we will distribute the moment. So the final answer will be this. These are incorrect sway moment. These are sway moment but incorrect. We need to multiply some correction factor which will equal to S upon S dash. S is already known. We have to calculate S dash, and S dash means equilibrium of this. Equilibrium of this. Remove all the forces. Remove all the forces from frame and apply that. For example, this is the applied sway force. Now we can calculate this S dash equal to this. Now we have to calculate this HA, this horizontal reaction. See how we calculate this sway analysis. During sway analysis, this was sway analysis, we have calculated the sway force. Now we will see that this is one support and there is no horizontal restraint in this direction. There is no horizontal. We will apply, for example, you will calculate this HA. So I calculated HA. In general it was 3.125 and direction is this. So this was HA 3.125, but structure is this. So how this force generate? We have not applied anything, means we have applied the same sway force S dash here, because this reaction is due to this movement, this pushing movement, right? This reaction is due to this pushing movement, means during this push we applied this much force, then only this reaction can develop. So S dash equal to this much, right? So S dash will be 3.125, and now you can calculate the correction factor S upon S dash, which is equal to 2. So corrected sway moment will be multiply 2 in these all values. These are the corrected sway moment, and non sway moments are these, and add these two. These are the final end moments. These are final end moments. Now using these final end moments we can draw BMD. Look how we can draw BMD. BMD will be like this. This is the corrected sway moments are minus 16. Minus means anti-clock, 0, 0 and 24. Plus means clock, right? Now we will draw BMD. So this is minus 16. This is 0. Join here, and this is 0 and it is minus 24. This is here. Now one value this and other will be this. By when we will calculate this ordinate, the means 16 plus 0 by 2 means 8, and PL divided by 4. So these two will be equal, means their difference will be 0, means this will cut here, right? So we can say that from here to here there is no bending moment in this leg. From here to here no bending moment, and here to here it will minus. Minus means shape is like this. Minus means tension in reference phase, and here plus means this and minus means this. So plus means this, minus means this, here is this, and here bending moment is 0, means straight line. Because you have heard about M upon I equal to sigma upon Y equal to E upon R. If bending moment is 0, you will say 1 upon R equal to 0, and 1 upon R means curvature. Curvature is 0, means beam will not curve, right? Beam will not curve, beam will not bend. ठीक. Next question. Next question is this. If there is internal hinge in the member, how will you solve? You can say that since loading is symmetrical but beam conditions are not symmetrical, means frame will sway. Frame will sway. First of all, we will do non-sway analysis. We will restrain it here and do the general analysis. We will calculate. See, here bending moment is 0, means MCB equal to 0 and MCD equal to 0, means no need to calculate distribution factor here, because here you in advance you know the bending moment MBC 0 and MCD 0. We will calculate distribution factor at joint B, B to C, B to A, B to A, B to C. Right. B to say B to E. Now we will calculate fixed end moment, assuming this and this fixed, the 0, assuming this and this fixed, 0. Now we will do some correction here, because correction is required, because here it is hinge, it is purely hinge, so it is 9, you will apply -9, and here this will be 13.5. all things are same as earlier. So now sway analysis, non-sway analysis, this is B, here 0 0, 13.25, anti-clock means -0 0 0. Now you will calculate its opposite and half here and half here. So these will be the final non-sway moment. Using these non-sway moment, we will calculate reactions, and then we will apply this formula, R equal to 2 reactions. Now we will calculate reaction. I do not know reaction will be in this direction. Let us suppose reaction will be in this direction. For example, now you say MAB, A to B is 3.375 and B to A is 6.675. This force HA. Summation MB equal to 0. You can calculate HA from here. Similarly here, C to B, bending moment is 0. These two load will be there, and here some load will be there. It is HD, and also at D it is 0, means HD will be 0. So it is 2.53, it is 0 and equal to R. So R will be 2.53, hence S equal to 2.53. Now we will do sway moment, sway analysis. How we will do sway analysis? Means assume this as fixed, so you will take this fixed, this fixed, this fixed, but this is hinge, so it fixed and it will hinge, right? So end moment will be 0 because there is sway in this direction, and there it is also hinge and it is also hinge, so no end moment will develop due to settlement. Remember, if structure is determinate, due to support settlement, no end moment generates. Same is here, it is hinge and it is hinge, right? So due to this, no end moment will generate. So end moments will be MAB, this is minus anti-clock, this is minus 0 0 0 0, minus 6CI delta divided by L square, minus 6CI delta divided by L square, 0 0 0, minus 1 minus 1. Let us suppose minus 10 minus 10. Distribute now. Final values are minus 7.5, this and this. Now we will again calculate that S dash force. In order to calculate that S dash force, remove all the loading and we will calculate only H, horizontal reactions, HA and HD. Now HA will be calculated in same manner. This moment minus 7.5 means anti-clock, this is minus 5 anti-clock, summation MB0, HA will be 3.125, means in the same direction, this is HA, right? And HD will again be 0, means you pushed the frame in this direction, means you applied some force S dash and reaction is 2.5, means S dash equal to 2.5, this equal to this. During this sway analysis, we remove all the loading and only apply the horizontal force at this joint, and we need to calculate this horizontal force, and this will be calculated using this analysis. After calculating the horizontal reaction, this force will be equal to summation of these horizontal reactions algebraically, right? So now distribution factor, we can calculate the distribution factor as correction factor as S upon S dash, which will be 0.8096, right? Now final end moments will be corrected sway moment will be this multiplied in this, so these are corrected sway moment, and now add these moments into non-sway moments, means in these 3.375, 6.3 and they, so these will be the final end moments. These are the final end moments. Now we can draw BMD. Now we can draw BMD. Look how we will draw BMD. This. Now you can draw easily BMD because we have made solved many questions. This minus anti-clock plus clock minus anti-clock 0 0. Right. This is 0 0. Now how to draw? look, this is reference face, this is reference face, this is, both arrow are opposite to reference face, means minus will be plotted on reference face. This is minus 2.7. Here minus will be plotted on reference face. Now you can plot this, and in this 0 0, so it will remain 0. Now in this leg bending moment is 0, means it will remain straight. However, sway will there, frame will sway, this leg will remain straight since bending moment is 0. And now its shape can be calculated as like this: negative, negative and positive. So this is negative like this, right? Because here it will remain like this, and here also it is like this, and now like this. Okay, this is the deflected shape. Now next question. Next question is this. He asks you analyze using MDM, moment distribution. Using moment distribution method, draw BMD. Okay, in order to draw BMD, you can say that there is single span beam, fixed end. This is 16 kilonewton. You can calculate the end moments, PAB square by L square and PA square B by L square. But that formula was there if beam is of prismatic cross section, means prismatic beam is prismatic, means of same cross section, and curvature is not broken, means there is no internal hinge. But if there is internal hinge, that formula is not valid, means we are not known these end moments, so we cannot draw these BMD. Now what is the procedure to draw BMD? We can see that let us assume this as support, and once if we assume as support, we will assume at fixed, this is fixed, end moment are known, PAB by L like that, right? P by 8, this is P by 8, this is P by 8, this is 0, this is 0. So you can assume as support, and now this support will settle, right? Because due to loading it will go down. So you can take as support settlement case, means sway. Sway means if settlement is not known, that is called as sway. But if settlement is known, you can easily calculate end moments, right? So in this case settlement is not known, so you will assume as a support, it is as a support, right? Now what will you do? First of all, you will do non-sway analysis, means support is not settled, this support is not settled. So how will you do? You will do, means you will catch it from this, you will put your finger here and stop beam to go down, right? And so this will be the non-sway analysis. So assume this as so this will be the case, this is fixed, 8 8 0 0, but this is hinge, pure hinge, so here should be 0, so it is 12, it is 0. So finally now what is there any need to distribute the moment? Here is 12, here is 0, here is 0, here is 0. So at this joint finally bending moment is balanced, here is 0, here is 0, and here we have calculated 12. So now we will calculate the sway force, means due to this how much force is applied in this direction, then only this will go down, right? So we will calculate the same procedure, right? So first we'll calculate RA, take a section here, this is RA, so end moment is 12, this is 12, here is 0, this is 16, so summation MB equal to 0, we will calculate RA. Similarly here summation MB equal to 0, we will calculate RC. Now we will use the equation RA 11, RC 0, this is 16, and we will calculate R, the same procedure which we have done in the last question. So R will be up equal to down, R will be 5 kilonewton up, means 5 kilonewton down, sway force will be there. So we are known here S equal to 5 kilonewton, we are known here S equal to 5 kilonewton, right? Now this is the actual sway force. Now sway analysis means you will apply some load and give unit delta in this direction. So since it is hinge, right? So either we can do the same manner, this is fixed, 6 EI is 6 EI, thereafter you will make correction, this will become 3. So if far end is hinged, better you will take 3 EI delta divided by L square. Similarly here, but it is hinged, it will be 3. It is cloak, so anti-cloak, it is anti-cloak, so it will be cloak. Value will be 3 EI delta divided by L square, 3 EI delta divided by L square, 0 0. So fixed end moments will be these, this 0 0, this. So ratio will be -1:4. So we will take -10:40, right? Now again no need to distribute because joint is balanced 0 0, right? So no need to balance. Now again you will calculate reactions. Actually in the sway analysis, again and again you have to calculate reaction in the first case and thereafter the second case. In first case using reaction you will calculate S force, and in the second case using reaction you will calculate S dash, and the ratio of S and S dash will be equal to the distribution factor, right? So this will be RA. Now you can calculate this RA. Using this you will cut here, this will be some force here, bending moment is 0, here will be some force, here will be some, this is RA, and it is -10 means anti-cloak. So you will calculate RA equal to 2.5. Similarly here 0, plus means cloak, so here RC will be +20. Now RA, again you will say that RA is up and this is 20. You will say that since you gave the unit displacement, right, means how much force you would have applied in that case. The beam was this, sway analysis means the beam was this was the beam. Now you gave unit displacement, means you stood over it and you gave the displacement delta, right? So what was your weight, means how much force you applied, that is S dash. So at S dash is 22.5. So correction factor is S upon S dash equal to this. Now in the same manner you can solve the question, means corrected sway moment, final end moment is this. Now -0 0 and plus, you can draw fixed end moment, this is minus anti-cloak, so up, here is 0, here is again minus, down, it is hitting down, so minus, and it is simply supported, right? Deflected shape will be like this, here this, here this, here this will be the deflected shape. And moreover at the hinge point, this is hinge point, here curvature will change, it is sagging, it is hogging, it is sagging, it is hogging, right? So because beam is discontinuous here, right? Okay, next question. The similar question is like this. He asks, analyze the beam using MDM. Analyze the beam using MDM. This is the beam. So this is load, two ends are there, it is one span, one load. So we can calculate PAB by L square, but the formula is that if beam is prismatic, beam is not prismatic, so we will do the same analysis. We will assume as a support which will settle, means we will do sway analysis. So in the analysis, first part will be non-sway analysis, means you will you will make some arrangement like that. You will take a bamboo and stick here, right, put here, so that it doesn't go here, so it will give some reaction. So you want to calculate that reaction, how much reaction is applied at C, and that reaction will be equal to sway force, because in this loading it will go like this, it will go like this, means some force would have been applied, then only it can go like down, right? However, force is 32, but here how much effect of this 32 is here, then that can be calculated using this. So you will calculate. So now you will do fixed end moment. This is fixed, this is fixed, this is fixed. Value will be -6, 18, 0, 0. Now you will calculate distribution factor CACB. In earlier case that was hinge, so it was 0, it was 0. But here values are there, so we will distribute the moment. So it is 2 by 3 and it is 1 by 3. So now distribute this and you will get value -12, 6, -6, 12. Now using these we will calculate these reactions RA and RB, and finally we will write RA plus RB plus RC equal to 32, and RC can be calculated. RA and RB will be calculated using these end moments. So using the we will cut this structure here and here. So we will cut here C to B there is moment plus 6 means clock, and B to C it is minus 12, this is means anti-clock. Here is RA, here is some force, this is shear force, this is axial force. Now summation of MB equal to 0, you can calculate RA 9.5. Similarly here you can calculate RB. RA is plus 9.5, this is down 32 R. So R is 24.75 using up equal to down this. So sway force is 24.75. Now we will calculate sway moment. That is sway analysis. These were the known sway moments. Right. Now we will calculate. We will do sway analysis. Means this is fixed and this is fixed. So analysis will be like this. This is clock. So these will anti-clock. This is anti-clock. These two will clock. So value will be M bar AB, BA, BC and CB. Value is this 6CI delta divided by L square, and these are clocks, so these will be plus, these are anti-clock, these will be minus. Ratio is minus 2, 1, 1. So let us suppose multiply by 10, so it is minus 20, 10, 10, right? However, since we know that distribution factor is 2 by 3, 1 by 3, we could also take a 9, 18, 18, then it will become easier, right? But generally we are taking 10, 10, so we can also take 10 also. So now again distribute, these will be the values. Now using these values we will calculate how much force we have applied. This is the structure now. This is right. Non sway analysis means we have applied some force S dash and structure is gone like that, like this. So we want to calculate this force so that it goes down, right? But actual sway force is that. So due to this sway force S dash, we want to calculate end moment, right? So we can calculate the corrected end moment due to that S force, right? So this is the thing. So A to C, C to B. Equilibrium of similar way, A to C and C to B. No load will be used here because now a loading is removed, right? So now summation MC0 RA will calculate it, summation MC0 RB will be calculated using this is RC, this is RB, RA, RB and this is S. So S will be this. Now the same procedure. This is sway correction factor, corrected sway moment, final end moment, and we will calculate BMD. This is this is minus and this is plus. So it is like this. This is plus, this is minus, like this, and BMD will be like this, right? Okay, set will be this. Now if he ask in the question calculate the delta, actual delta, we will say that when moment was this, how much? Minus 2, right? You can say that, sorry, this when moment was, you took minus 20 now, when moment was minus 20, sway was minus 12 VI by delta square. So when minus 20, so minus 12, so this delta is this, but this is not correct delta. You have to multiply this correction factor, you will get actual delta 48 upon EI, right? Next question. Next is if frame has inclined leg. For example, this is the question, frame with inclined leg. This is the question. Now due to loading, so first step will be same, fixed end moment. We will calculate fixed end moment, right? These are calculated as fixed end moment. Thereafter this is fixed end moment calculated, and you will put like this, and first discussion will be same as we have discussed so far. But now second step will be, now you can calculate this R and this R will be S. Now you will apply sway force, means S is calculated, you will apply sway force, means you will push in this direction. So you will see that this is vertical lag always goes to its perpendicular, this is inclined lag always goes perpendicular to this, right? This is 90. Okay, so this joint will go here, this joint will go here, right? So lag will be like this. For example, like this. The deflection of this frame will be like this. Now how will you calculate this delta? Delta is 1 only, so you say that if this is delta, this is delta, right? So sway analysis, how you do sway analysis? Remove loading and give delta in this direction, means push this frame in this direction. I assume this is delta. Now can I calculate? This point is goes from horizontally, this point goes horizontally like this, and these two are same, because this point horizontally will move equal to this point as horizontally this move, right? So but our analysis is like this, assuming the end as fixed end, means this is fixed and this was the earlier case. Now this has become like this, this is clock and this is the delta. But in this case, this member, this is down and this is up. So how much is this delta? You have to calculate this delta. So let us suppose this is equal to theta. For example, this is theta. So if this is theta, so this value equal to theta. If this theta and it is 90, so it will theta. And if this is theta, you can say that this is delta, so it is delta cos theta and it is delta sin theta. It is delta cos theta, it will also be delta cos theta. Only this is the discussion, means this value will be delta sin theta, and for this column you will write like this, assuming all and as fixed, this will be delta cos theta, right? Now you can write down sway equation. This is like this and like this, 6 ci delta divided by L square. This is anti-clock, these will be clock, and this is clock, so these will be anti-clock. So 6 ei delta means delta cos theta divided by L square. Same is here. Here 6 ei delta sin theta divided by L square, and here 6 ei delta divided by L, means there is only one unknown, delta. Now we will calculate this sway force S dash, how much we have applied so that this delta is created. So we will write down this equation, HA, and this is, let us suppose, HD. So you will write HA plus HD equal to S dash, answer. But how to calculate HA? So you will see that in order to calculate HA, you will have to use this. See this is HA, this value, this and this. If I take moment about this point MB equal to 0, in the question these two are known, this is this has to calculate, but this is not known. It will also appear. How to calculate it? This is equal to this and this is equal to this. Can it be calculated? This is, for example, this is RB, this is RB, this is RC. Can we calculate this RB? Because we know these moments. This moment we know, this moment. Loading is not applied now because this is sway analysis, and you will do, this is B, this is C. Summation MC equal to 0 means RC will be 0. So everything will be in terms of RB. You can calculate RB, and using this RB you can calculate HA. Similarly, from this discussion you can calculate HD using these moments. HD, you can calculate HD. right? And HA plus HD equal to S dash, and remaining procedure will be same. Let us solve one question. Let us solve one question. However, this question is not asked so far in any exam, but some people say that any time this question can be appeared in engineering service exam, anytime. So we should solve this question. Inclined lag question. Inclined lag. Let us suppose question is this. This is the question. And moreover, listen, if vertical loading not been there, and the question would be like this. In this case, means it is equal to S. Sway force. Sway force is 100. Now we will do only sway analysis. Means non-sway moments will be 0. So let us solve this question. See how. Let us solve this question. First aim is non-sway analysis. Means we will restrain frame here and do general analysis. General means assume this and this fix, no loading, so end moment will be 0. Assume this and this fix, loading is this, end moment is this. Assume this and this fix, this is 0, means loading is 0, means these moments will be 0. Now we will calculate distribution factor. Far end is fixed, so 4EI by L, 4EI by L. Far end is fixed, 4EI by L, 4EI by L. So we will calculate distribution factor. These are the distribution factor. Now we will distribute these moments. This actually the question, if we will ask in the examination, this will be a minimum weightage of 30 marks because it is too lengthy question, right? So generally it cannot be asked, but we should solve the question so that our concepts are refined. So now we will distribute the moment 0 0 32 32 0 0 0 0 minus 32 plus 32 0 and 0, right? Now we will keep on distributing. Finally we will get such a table, right? Now what was our step? Using this we would calculate HA and HD, and finally we will write HA plus HD barabar S, right? So in order to calculate HA, look here, you will cut here. So this is RA, this is HA, this is RB, this moment, this is plus means clock 9.5, this is plus means 19, right? Summation MB equal to 0, but in the question this RA will also appear. Look, RA into 3, RA into 3. How should we calculate RA? So this is the one extra step in this type of questions. Means in order to calculate this RA will be equal to this RA, and this RA will be this RB. Means you will calculate this, and this will be calculated summation MC equal to 0, equilibrium of BC, because B to C, this is minus 19, anti-clock, this is 21.86, this is UDL, right? So you can calculate RB equal to this. Remember, in first case complete loading will be there, but in second case sway analysis loading will be removed, right? So, and in this, for this lag, this is minus means anti-clock, this is plus means this is minus again anti-clock, and this is HD, this is some vertical force, this is vertical, this is, so summation MC equal to 0, we can calculate HD. Now we will calculate, we will see that HA, this is HA, in look, we can take the direction of HAHD in any direction. I could take HA in this, answer would be negative, right? I could take HD in this, answer would be negative. So it is our choice in which direction we will take. So since both are positive, means our assumption is correct. That's why now we will calculate sway force R. How will we calculate? This is HA, this is HD, and this is R. This equal to this. Summation Fx into 0 means HA will be, means this R equal to this sway force is 34.39. Step 2. Step 2 means we have to do the sway analysis. Means we have to apply some force in this direction, which will be S dash, which we have to calculate. Due to this, frame will go in this direction, and we will calculate this S using S dash equal to HA plus HD, right? S dash equal to HA. So our aim is to calculate this HA, and which will be calculated using these end moments by taking the equilibrium of this lag, right? So now you will write equilibrium, this, that is sway analysis. So assuming this end edge fix, look here, assuming this edge fix, this is C, this is